Okay. Next in geometry, you have a quiz. Quiz number 3, but let's review a little bit first. We've talked about inductive reasoning, and we've talked about deductive reasoning. Remember, inductive reasoning is when we draw conclusions from a limited set of examples. Okay, kind of like a commercial. They show you a few people that tried this product and this is their results, and so they want you to conclude that this is the conclusion. This will happen every time. That's inductive reasoning. And we've discussed deductive reasoning. Remember, deductive reasoning is, we start with a statement that everyone agrees to be true, and we look at examples to see if they fit the conditions. If they don't fit the conditions, then we should logically accept the results. Okay? The test is really to determine the validity of the postulates. For example, Thanksgiving is on a Thursday. Today is Thursday, so today is Thanksgiving. That may be true if today is Thanksgiving. Okay. Inductive reasoning takes general observations and it attempts to arrive at a specific conclusion. Deductive reasoning takes a specific observation and creates a general conclusion. Alright, so here we go. I want you to try to answer this before I do. If Desi is younger than Jamin, and Jamin is younger than Craven, then Desi is younger than Craven. What type of reasoning is this? Is this inductive reasoning or deductive reasoning? If Desi is younger than Jamin and Jamin is younger than Craven, then Desi is younger than Craven. Okay. You should have said this is deductive reasoning. And the reason it's deductive reasoning is because I can use my theorems and postulates to prove it. Okay? Desi, I'm going to call Desi A. Desi is younger than Jamin, so I'm going to call Jamin B. A is less than B. And Jamin is younger than Craven, so Craven is C. Then Desi, which is A, is younger than Craven, which is C. Does that formula look familiar? I forgot the word if. Okay, that's a transitive property, isn't it? So we can use deductive reasoning because I can use my theorems and my postulates to prove it. Alright, let's try another one. Let's say in my garage, the wall and the floor meet in a line segment. Okay? The wall, here's the wall, here's my wall, okay, and here's my floor. They meet in a line segment. Is that inductive reasoning or deductive reasoning? Okay, that's still deductive reasoning, because I can still use my postulates to prove it. Whenever two planes intersect, they intersect at a line, right? Okay. Well, let's try another one. What if I'm at a baseball game it's the middle of the first quarter and I say KU is going to win this game, what kind of reasoning is that? Is that inductive reasoning, deductive reasoning, or neither? Well, it's not deductive reasoning. I don't have a theorem that says do this formula and determine if KU is going to win. It's not inductive reasoning. That's just a guess, isn't it? So that's neither. All right, let's try another one. Now, I'm going to give you a statement, and I want you to write a conclusion. Are you ready? X is a number. X is a number. That's the abbreviation for number, N-O period, such that (8x = 24). Okay, now I want you to write a conclusion. Stop the tape, write a conclusion, and then compare it with mine. Alright, well, here we go. You should have divided both sides by 8. X = 3. How'd you do? Did I trick you on that one? Let's try another one. I lost my place. Okay. Remember, you can use your theorem sheet. That's fine. All right. If P, then Q, is false. Okay? And P is true. What is Q? Q is what? Stop the tape. Look at your chart if you need to. Tell me what Q would be. That's a horrible Q. Okay, did you look at your truth table? Did you find the conditional? Look at the two conditionals that are false. Look at the conditional that's false. There's only one. What is Q? When the conditional is false, what is Q? Q is false. That's the only time that it's false, is if P is true and Q is false, because all the other times it's true, right? Alright. Okay. Let's say we're watching the movie Despicable Me. And he invents this machine, okay? And he pushes the button and that little guy, whatever he's called, he makes a face and falls over. Okay? Then he presses it again, and a couple more of them do the same thing. They make a face and they fall over. So we conclude that that spray that he made smells terrible. What kind of reasoning is that? Is that inductive reasoning, deductive reasoning, or neither? Okay, that's inductive reasoning, because we watched it, how it compared to a few of them, and we made a conclusion. Okay? Actually, in that situation, I know in the movie they actually tell us what type of gun it is. But anyway, here we go. What if I said, 2x plus 9 equals 13. 2x equals 9. X plus 9 equals 13. If 2x plus 9 equals 13, then x equals 2. What kind of reasoning is that? Okay, well, I can prove this one, right? Subtract 9 from both sides. Those cancel out. I have 2x equals 4. Divide 2 by both sides. X equals 2. I can prove it. So that's deductive reasoning. Anytime you can use your theorems or you can prove it, you can go through a process to prove it, that's deductive reasoning. Inductive reasoning is more like a guess. You assume it. Let's try again. What if I say x is an integer between negative 1.6 and negative 0.6. X equals what? This time I don't want to know what type of reasoning is. I want you to solve it. What would X be? Okay. Well, if you know your integers are whole numbers and their opposites, right? So 0, 1, 2, 3, 4, 5, and their opposites. So these are my integers. My integers are 0, 1, 2, ... And their opposites. The opposite of 1 is negative 1. The opposite of 2 is negative 2. So which one of these is between negative 1.6 and negative 0.6? Well, negative 1.6 is going to be right here. Negative 0.6 is going to be right here. The only integer between those is negative 1. So x is negative 1. How did you do? That is deductive reasoning, by the way. Okay. Alright. What if I said, now there's questions on here using those truth tables. Make sure you have the truth tables there. Okay? True or false? You can always prove a conclusion by inductive reasoning. True or false? You can always prove a conclusion by inductive reasoning. False. When X and Y are statements X or Y is called blank of X and Y. Okay. You should have said X or Y is called the disjunction of X and Y. What type of reasoning, is it inductive or deductive or neither? Which type of reasoning do you make a conclusion by looking at several examples? Which type of reasoning do you make a conclusion just by looking at several examples? Okay, it's inductive reasoning. Okay, I'm going to give you a statement. I want you to tell me what the contrapositive is. Okay? Let's see. If I wash my hair, it will shine. Okay, I want the contrapositive of this statement. And I hope you're doing it and not just sitting there and waiting for me to tell you the answer. Okay. Contrapositive means I have to switch the order and I have to negate them. So I should have said if I if it will shine. If my hair doesn't shine, I didn't wash it. Okay, remember contrapositive means that we have to switch the order and negate them. Okay? Okay. Now, let's practice a couple proofs. Are you ready? What if I have four x plus 1 equals x plus 16. Okay, are we ready? Here we go. The first thing we have to do is, and I know usually when I do algebra, I usually do 2 steps at a time right here, but because we're proving it, we're going to have to break it down to 1 step at a time. So it doesn't matter which way you do, whether you put the x all on one side first. I usually take care of the x's first. So let's subtract x from both sides. It's okay if you did it the other way. Those cancel out. So I have 3x plus 1 equals 16. What did I do? I subtracted. So this was the subtraction property. And I'm just going to put subtraction property. We know it's of equality. Okay. Now what do? I forgot my 1. Wow. Well, I still have numbers that I'm going to have to subtract 1. Those cancel out, so I have 3x equals 15. What did I do? Well, I subtracted again. So again, this is the subtraction property. Okay. Now what do? Well, I have to divide by 3. X equals 5. What did I do? I divided. This is the division property. Okay? Make sure you know those algebra properties. Okay. What if I said if P implies Q is true, and Q is false, what is P? Look at your truth table. Okay. Well, you should have looked at your truth table, and if P implies Q is true, and Q is false, what is P? Well, if you look at your truth chart, if Q is false, the only thing P can be is false. Okay? Remember, look at your truth table. What type of reasoning do I fit a specific example into a general statement and to reach a conclusion? Which type of reasoning do I fit a specific example into a general statement to reach a conclusion? Okay, you should have said deductive reasoning. Okay, if you had problems on any of that, I want you to go back and study it, make sure you know it. Alright, you may use your truth table, you may use your theorems and your postulates. Okay, as far as your algebra ones, you're going to have to memorize those. Alright, make sure you know this before you take this quiz.